Hi guys, say I said to you my daughter was 150 centimetres tall at one point and her height went up by 2% one year and then 3% the next year, and I wanted you to find out how tall she was. Well, what you could do is you could say, okay, if I did 150 times 1.02, I would get 153 centimetres tall. And then if I want to go take that up by 3% times by 1.03 to give me 157.59 centimetres. Okay, now it made not have escaped your notice, but I didn't actually press clear or cancel on my calculator. What I did was I pressed 150 times 1.02 and then I went straight on to times by 1.03. So I could just put it all in one go. So 150 times 1.02 times 1.03. And that does give me 157.59 centimetres. Now, say my son was 160 centimetres and he grew by 3% a year for 3 consecutive years. I could say that he multiplied by 1.03 for the first year, 1.03 for the second year, and 1.03 for the third year. Now, it shouldn't be too much of a step to see that if I've got something times by itself 3 times, I can say that's 160 times 1.03 cubed. And I can do that really quickly. 160 times 1.03 cubed would give me 174.8 centimetres if I round up to one decimal place. So when the change is the same change, we can use a power. So let's think of a different example. Say I had a car and it was worth £9,000 and it went down by 5% per year for 8 years. What would it be worth then? Well, I'll start off with my 9,000. Now if it's going down by 5%, the quick way of doing that is to multiply by 0.95. But I'm going to do that again and again and again and again and again and again and again. In fact, I'm going to do it 8 times. Because I'm going to do it 8 times, I'm going to times by that to the power of 8. So I get 9,000 times 0.95, so that's taking 5% off, but I'm going to do that for 8 years. So I'll put power of 8, let's see what it's worth. £5,970.78. Now, where this often comes in is in banking, and we look at something called compound interest. And that means you make an investment and then the bank pays you a percentage on top of it for having your money and using your money. So they pay you interest back. So for example, if you put £100 in, they might give you 2% on that £100 for that year that you have it in. Well, let's say you put £100 in the bank and the interest rate was 2%. Now they put PA, that means per annum. That's Latin, it means every year. So 100%. Now interest means you're going to have more money at the end of the year, so it's going to go up by 2%. So the multiplier is 1.02. And then you have to think about, right, how many years would I have that in the bank? So let's say I had that in the bank for 10 years. So I say it to the power of 10. So I have 100 times 1.02 to the power of 10 would be £121.89. So not a great improvement, because interest rates are really low at the minute. That's to encourage people to borrow lots of money, because that's where the bank's finances come from. And if people aren't borrowing money, the economy stales. So interest rates are all related to, right, we'll give you this much money to borrow, give this much to use your money, but it's when we lend it to other people that we really coin the money back in. But if there's not many people wanting to borrow money, then that causes the banks to not make much money. So their interest rates are low to encourage people to buy. So the idea is, if it's the same change every year, whether it's going up as an interest or in depreciation, as in like something that you own, then you use a power. But you think about that multiplier first. So it's going down by 5%. That creates the 0.95, which we've done quite a few times. And then the amount of years brings in the power. Here, this one's gone up 2%. That created the 1.02. And then the amount of years created the power. Okay?